Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math geometry problem, and here we have a right triangle in which the length of one side is n cubed, the length of this side is n plus 2 whole cubed, and the length of this side is denoted by square root of 2. And you know that the side opposite to the right angle is known as the hypotenuse, and this side is called the base, and this side is called the perpendicular of this right triangle. And now here we use the Pythagorean theorem in order to find the values of n. So that here we first write the Pythagorean theorem. So you already know about the Pythagorean theorem. It is stated as hypotenuse square equals to base square plus perpendicular square. So this is called the Pythagorean theorem, and now we put the values of HBP here, and you see in the diagram we have h equals to square root of 2, b is n cubed, and p is n plus 2 cubed. So that when we put these values here, then it will be equals to square root of 2 and its whole square plus b will becomes n cubed and its whole square plus p is n plus 2 cubed and its whole square. And now in the next step we simplify the terms, and first we write this term in the left hand side as n plus 2 to the power of 6 plus, when we multiply these two exponents, then here we get n to the power of 6, and in the right hand side we have these 2 and square root are gone, and we get here 2. So now we simplify this nice equation, so that here first we make a little bit simplifications, and we rewrite this equation as, we write this n plus 2 as uh, n plus 1 plus 1 and its whole power 6, plus we write this n to the power of 6 as n plus 1 minus 1 and its whole power 6 equals to 2. So that here we take n plus 1 be the common expression on both of the bases. So we take here y equals to n plus 1. So when we take y equals n plus 1, then the above equation will becomes in this way: y plus 1 and its whole power 6 plus y minus 1 and its whole power 6 equals to 2. And now we solve this equation, so that here we first take a equals to y minus 1 and we take b equals to y plus 1. So here we take these two substitutions, and now when we take the square on both of the side of this expression, then we get a square equals to, when you take the square on this expression, then we get here y minus 1 whole square, and y minus 1 whole square equals to y square plus 1 minus 2y. Similarly, when we take the square on this side, this equation, then you get b square equals to y square plus 1 plus 2 times of y. And now here we make some values here. So when we add these two equations, then we get here a square plus b square equals to, here you see that after adding these two equations, this negative and positive term are cancelled by each other, and we get here 2 times of y square plus 1. And similarly, when we multiply these two equations, then you get here a square multiplied by b square. Then here you see that this is the our first term, and this is the first term, and this is the second term. When we multiply these two terms here, then you get y square plus 1 and its whole square minus 2y and its whole square. So we get here these two equations, and we call this as equation number 1 and this as equation number 2. And now we put the values of a and b in this equation, then we get here a to the power of 6 plus b to the power of 6 equals to 2. And now here our next target is to simplify this equation, so that we rewrite this equation as a square and its whole cubed plus b square and its whole cubed equals to 2. And we open the cubic formula here, and you know that a cubed plus b cubed equals to a plus b times of a square plus a square minus ab. So our a is a square b square and plus b square. So our b is again b square and its whole square equals to 2. And now from equation number 1, you see here we have the value of a square plus b square equals to 2 times of y square plus 1, and the value of a square times of b square is this one. So we use these two values here, and we write this equation as a square plus b square into here we obtain this value as a square and its whole square. We write this minus a square and b square as plus 2 times of a square b square, and plus we have this value becomes b square and its whole square minus 3 times of a square and b square, and this whole equation becomes 2. So here we just rewrite this expression as this is minus a square b square. We write it as 2a square b square minus 3a square b square. So when we subtract 2 minus 3, we get minus a square b square. And now we put the value of a square and plus b square here. So we get a square plus b square equals to 2 times of y square plus 1 into, when you focus on these terms, then you see that it will becomes a square plus b square and its whole square. So it will become the completing square of a square plus b square, and we have minus 3 times of a square b square, and this whole equation becomes 2. And now we again put the value of a square plus b square here, and we substitute the value of a square multiplied by b square here, so that we use equation number 1 and equation number 2. So this implies that we have 2 times of y square plus 1 into, here we put the value of this expression, it is 2 times of y square plus 1 and its whole square minus 3 times of the value of a square and b square from equation number 2 is y square plus 1 whole square minus 4 times of y square, and this whole equation equals to 2. So now in the next step we here we need to simplify the terms, and we write it as 2 times of y square plus 1 into, if you focus on this expression, we have 2 times of y square plus 1 whole square, so it will be equals to 4 times of y square plus 1 whole square minus 3 times, we multiply this 3 on both of these terms, and we get 3 times of y square plus 1 whole square, and plus 3 times of 4 is 12 times of y square equals to 2. And now we simplify this equation, and we have 2 times of y square plus 1 into 4 minus 3 becomes y square plus 1 and its whole square plus 12 times of y square equals to 2. And here we again make some substitution, and we take here t equals to y square plus 1. So when we put this value equals to t and we get the value of y square here, y square becomes t minus 1. We put these two values in this equation, and we get 2 times of t into, here we put the value, you get t square plus 12 times of the value of y square is t minus 1, and this whole equals to 2. So now we again simplify these terms, and we multiply uh, this t on both of the terms, but here first we divide 2 on both of the sides, because this 2 is cancelled out by this 2, and we get t times of t square, plus we multiply this 12 on both of the terms, and you get 12t minus 12 equals to 1. And now we multiply this t on each term, and we get t cubed plus 12t square minus 12t, and we move this one in the left hand side, and it will becomes minus 1 equals to 0. So here we rearrange these terms as t cubed minus 1 into plus we write these terms as 12 times of t square minus 12t equals to 0. So here we use the cubic formula here, and you get t minus 1 times of t square plus t plus 1, and plus we take common 12t on both of these terms, and we get t minus 1 equals to 0. So here you focus on these two terms, and you see that we have t minus 1 be the common expression, and we get t square plus t plus 1, plus here we get 12t equals to 0. And now we simplify the terms, and we get we convert this in two cases, and our first case is we write t minus 1 equals to 0, and the second case is we write t square plus 13t plus 1 equals to 0. So now in the first case you get the value of t equals to 1, and when we back substitute the value of t, so our value of t is y square plus 1 equals to 1, and you get y square equals to 0, and we have y equals to 0. But in if you focus on this case, so this case cannot gives us the real solution. When you check the roots of this equation, and you see that it can't gives the real solution. So because our uh, n be the sides of the right triangle, so it must be real. So here it gives no real solution, and we rejected this case, and we can just proceed here this case only. And in this case we get y equals to 0, and when we again back substitute the value of y, then you see here we have y equals to n plus 1, and we put the value of y. So this will be written as in this form, and we have y equals n plus 1 equals to 0. So you get n equals to minus 1. So here we get the value of n equals to minus 1, but it cannot possible, because we know that our n be the side length of this right triangle. Here you find the value of n equals to minus 1. We get only single value of n, which is minus 1, but our n be the side length of this triangle, and when you put this value here, then you get our the length of this side becomes negative. So because our n cubed equals to minus 1, and you know that the side length of any triangle cannot be negative, so that it is not possible. So we rejected this case also, and we finally conclude that in this question we cannot have any real solution of this equation, or we cannot find any real value of n. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.